So one last thing I wanted to show you real quick is when I made mention of using the zero network for a subnet. So let's say you've got a pretty big network. Let's say you've got offices in Dallas, Los Angeles, New York, and you've got some big routers that are all connected via SONET, and you need and this is all going to be one big corporate network, and these are all Class C's. These clouds are all Class C's. They're going to have their own routers, all broken up, just like the way we were breaking up the 192 network earlier. And that's kind of what I was meaning when sometimes you can't use any IP you want to, because if you're in a big corporate LAN like this, they might already be used, and you might be struggling for IP addresses, even though they are private. And so the network folks, they have to or the operations folks have to keep up with all this, and this small of a network right here with 3 routers is not that big of a deal. 172.16.1.0 network. Let's say it's a Class C. Okay, let's say all these are Class C's. And you need to figure out, okay, I need to break up a network, or I need some small point-to-point subnets for my point-to-point connections here. And that's what I was showing you earlier. I said, well, you take the I usually take the zero network in this case. So I reserve zero for all the major routers. Like these guys might be a whole bunch of these out here, and they might be running a Border Gateway Protocol, BGP, and all these guys down here are running all OSPF or ISIS or something like that. And so you want to have your core routers, if you will, all point to point like this, and they're usually in small networks. So this would be like the zero. It might be easier to draw actual IP addresses, but this is going to be the 0 with a 252, and that comes back to our Excel spreadsheet that I've already closed. But let's say like this interface right here would be oh, I did put some. So this will be dot 1 right here, and this will be dot 2 down here. And then so that would be that network, and then this right here would be the 0 dot 4 network. All right, and this would be 2. I have too many 255s in there. Wow, my typing is not done. Okay, so 255, 250, yeah, okay. And so now this one would be your dot 5. This would be your dot 6. And so next on the hit list, which is 4 after that, is going to be 8. Oh, sorry, this is right. Yeah. So the broadcast would be 7. So the next wire address would be 0.8, and this would be 252, and this would be 7 and 8. So yeah, so that way, and so you save the whole zero network for basically your core routing, and hopefully you don't need more than a Class C for it. Otherwise you'll have a lot of rework to do. But if you only have 3 routers, it's pretty easy to build in static routes. So you say, okay, in this router right here, to are these routers right here. To get to this network has to have a route to this router here. It says so the 172.16.1.0 network lives off of, it's via this interface right here, this router right here. So you send the traffic this way, and this one sends it up this way. And that's where your routing protocols come in handy, because you can be running, BGP right here, and then OSPF on these guys, and then if you add, let's say you add another network right here, and what BGP does, it advertises these other routers. Okay, here's where I've got this subnet that lives. This Class C subnet lives right on this router right here. So these guys automatically know. So if you come in here and all of a sudden add another network on here and just tie it right into to this router right here, it's going to automatically get pushed to the rest of the routers, so you don't have to keep adding static routes, and it makes it a lot easier. Like I said, on a three router network, it's probably harder to set up BGP than it is just to add the static routes. But when you start getting 50 or 100 of these routers, then it becomes a big deal. So anyway, I think that's about it. I've covered quite a bit today. If anyone has any questions or comments, please let me know, and leave it in the comments. I'll try to answer them the best I can, and hope you enjoyed it. Thank you. So I noticed I made a mistake when I was just IPing these routers from the top of my head. And this is why it kind of comes back to where the spreadsheet is so handy. It might seem a little anal retentive, if you will, but it's real easy. You can see where I just completely goofed everything up. I put the broadcast for this network on this interface, and then the network ID that I just written out on this interface. So this definitely would not work like that. And I put it on a spreadsheet right here so we could look at it. So the 0 right here, this is the wire address right here, start at 0. So router 1 to router 3, which is this link right here, should have a .1 and a .2. Okay, and that's correct. And the broadcast is .3. So the .4 wire address, which is right here, should have a 5 and a 6 from router 1 to router 2. And that's correct right there. But the .8, which that's correct, the wire address from router 2 to router 3 should be 9 and 10, not 7 and 8. So this is why it's important to lay this stuff out, because you will send your, well, a lot of times the routers won't even let you do it. If they know, if you plug in this 252 and something it doesn't like, if it doesn't make sense, it doesn't meet the rules, I should say, it'll usually spit it back out of you, but sometimes it won't. You might just get lucky, and then you'll be scratching your head why nothing's working. And one of the things I mentioned that I wanted to show you, and I didn't, was the weird 254. So let's go over our spreadsheet. So do you remember our, let's see, where is it? Oops. Yeah, so remember our allowed subnets, 1, 2, 4, 8. So, and I said the 2 is a special case. Well, that special case is right here. So the subnet mask for that would be, see, it's 256. Oops. IP address, subtract 2, and that's going to give you a subnet mask of 254, right? And so you can use that right here, and then you would, instead of having a wire address and a broadcast address, you just have 1 and 2. And so you free that up. And some routers, so you don't have the 0. So you could theoretically, and I don't know if I've ever tried this, you could theoretically put a 0 and 1 right there. Okay, so you don't really have a wire address. And so you put, it might be easier just to do it like this. So this would be 0.0, and this guy right down here would be 0.1. Okay, with that 254 subnet mask. Some routers support this for this point-to-point, and what that does is that you can see that the wire and broadcast. If you do that for the whole subnet, you're going to have 127 wire and broadcast. It's going to chew up half your Class C, and so that's very wasteful. And so some routers allow it, some don't. I usually don't do that unless I'm just absolutely, running out of space, and then I'll start looking at that. And I have used it in the past, but like I said, I don't use it very often. And the other special case I want to talk to you about was, real quickly, is the 172 is the single IP address. So that's where, let's say you have a box. Let's just draw a box, and let's just call this. Let's say it's a piece of test equipment, and its IP address would be 172.16.0.3, for instance. Subnet mask of 255.255.255.255, and that's where it's the sub. This is just one single IP address hanging off this network right here, or off this router right here, and the way that gets routed is you basically just make a static route and just push it out to the network. That's where the other weird case comes in, but and that comes back to this case where you don't want to just smoke all your IP addresses with wire broadcast, and and doing the same thing right here where you have a wire broadcast and one piece of equipment hanging off of it. Especially if this is like a test set on each router, there might be multiple test sets, checking delay and basic network metrics. You could chew through a bunch of IP addresses in a hurry. So, but like I said, a lot of routers support it. A lot of them don't. I'm sure almost all the big core networks probably support it. Your Cisco's, your Junipers, that sort of thing. So anyway, I said I'd bring that up, and if someone knows if we could use this 0, I'm guessing you can. I have never tried it, but if they know, that would be interesting to find out. If you want to contact me, you can contact me through Muxall at www.muxall.com. Thanks.